Bonjour mes amis, les enfants et tout le monde. Aujourd'hui, Monsieur Benjamin ici, sans Madame Thériault et Madame Podlipski. Alright, so I'm sorry about that. I'm going to put a big frowny face for speaking in French. Not that I don't like French, it's just I'm not very good at it. I was actually talking to a couple students today about teaching French, and I figured I could do it, but to be honest with you, it took me like 5 minutes just to think about saying that, so I don't think I'm going to be doing it. No French teaching. Sad face. But anyways, that's not what we're talking about today. Today we are going to do a review video on our equations for our systems in action units. Now, we've quickly gone through 3 equations, and we're going to go through each individual and talk about how to rearrange it and when we need to use them. First of all, we have the force of gravity, which we can also call weight. Weight being different from mass. Mass is the amount of space or the amount of content within an object, whereas weight is that amount multiplied by the gravitational pull of the area. So the way we calculate the force of gravity is we use Fg, which is the force of gravity, is equal to m times g, where m is the mass of the object. And it's usually in kilograms. And g is the gravitational pull of the planet or of the area. I'm not going to fit it, but that's okay. Now for Earth, g is always 9.8 newtons per kilogram. It is a constant, meaning that number cannot change while you are on Earth. So all of that information is fine and good, but we're going to talk about when we use this and how we use it, and if we ever need to rearrange it, what that's going to look like. So again, our base equation, F equals m times g. Force of gravity is equal to the mass of the object times gravity. If we are ever asked to find the force of gravity on an object, that's what we're going to use, F equals mg. But we will often be asked to find the gravitational pull or the mass of the object. The way we do that is by rearranging this set equation. So for example, if we wanted to find m, first thing we're going to do is isolate it. The way we do that is by looking at the equation and saying, okay, F is over here by itself, force of gravity, m and g are on the same side. We want m to be by itself. So what we're going to do is we are going to divide both sides by g. The reason for that is if we divide this side by g, we will cancel out g, we will cancel out gravity, but we can't just divide it on this side. This equal sign right here means anything you do to this side, you have to do to this side. So, since we divided the first side by g, we have to divide the other side by g. So, f divided by g. These g's, like I said, cancel out, and we are left with fg equals m. F over g is equal to m. I'm going to write that out again. M is equal to F over G. So if we ever wanted to find the mass of an object and we are given the force and the force of gravity and the gravitational pull, that's how we will find it. Similarly, we can find G. We can solve for G as well. We will do the exact same thing, but instead of isolating M, we will isolate G. I'm going to write all of these 3 out in one simple way, and I'll show you how it works. First thing I'm going to do is draw a triangle. And F is going to be on top, M is going to be on this side, and G is going to be on this side. What this means is, to solve for F, we would write F is equal to M dot G, M times G. I'm going to write that again because it doesn't look very good. F is equal to M times G. To solve for M or G, we can look at it in a different way. M, since F and G are already, well, F is on top of G, we're going to write M is equal to F over G. So if we want to find M, you would take the force and divide it by the gravity. And for G, to find the gravitational pull, it's F over M. These are our 3 equations from this one set triangle. We've also talked about work, and what work is and how to find it using the equation W equals F times D, where W is the work performed, and that's in newtons, or in joules, excuse me. F is the force, that's in newtons. And D is the distance, which is usually in meters. So if I have to move a box a certain amount, a certain distance, that's what we're going to know. F is the force in newtons. It's usually the force required to move it. And W is work in joules. So we are going to look at this again if we have to rearrange to solve for force or to solve for distance. But before I do that, we're going to remember that this F here, force, if we are not given this value, if we are not told that there's a certain force working on it, we can actually find force if we are given gravitational pull. Because like we just saw, F is equal to mg. Next page, force. F is equal to m times g. Keep that in mind, okay? Now, we want to solve for force if we are given the other two values. If we are given W and D, work and distance, we are going to isolate F, which means we have to divide both sides by D. Cancel, cancel, cancel. Divide by D. So divide this side by D, and since we divided this side by D, we have to divide the other side by D because it's an equal sign. The D's on this side cancel out, and we are left with W over D equals F, or F equals W over D. Now it's the same thing if we want to solve for D instead of F. We're going to erase everything, and easier this way. We're going to write work out again, and we're going to draw our equation triangle. So work goes on top. We're going to put F on this side and D on this side. So solve for work. Work is equal to force times distance. Solve for F. F is equal to work over distance. Solve for D. D, distance, is equal to work over force. These are the three equations that we might have to use. And they can all be found by rearranging our first equation, which was W equals F over D. Mechanical advantage, exact same idea. MA is equal to F out over F in. If we want to draw our triangle, MA is on this side, F out is on top, and F in is on the inside. So what I'm going to ask you guys to do for our try this is to list off the three equations. List or write. Write sounds better. Write the three equations for mechanical advantage. So that's MA equals, F out equals, and F in equals. What are those three? So you should be able to show me. You should be able to write this. Have it on a piece of paper. Show me tomorrow. MA equals something. F out equals something. And F in equals something. Use the triangle. Use the force, Luke. Use the triangle, students. Use this. It'll help you out. This video is becoming a bit too long, so I'm going to say thank you. And have a great day.